Last summer, I had an internship at an auto body parts supplier. Similarly to most internships, I had quite a bit of downtime, so in an attempt to be proactive, I was conducting my own research online, taking notes on things I was interested in the back of my project notebook. And this included anything on a wide range of topics, from electromagnets to surface inspection plates, all the way through autonomous technology. While I was on the company website, I came across a list of our customers. So I thought it would be a good idea to kind of look into these companies I hadn't heard of before, get a better understanding of what these customers did. I reached a company called Daimler, which I thought I hadn't heard of before, but upon going to their website, I discovered they're actually one of the world's largest automobile manufacturing companies. They owned Mercedes-Benz and Maybach, just to name a few. Their company's strategy was displayed pretty largely on their website, shaping the future of mobility in a safe and sustainable manner. By clicking on the strategy link, I was taken to a page with an abundance of articles about the future of the automotive industry. The one that really caught my eye, however, was the link to autonomous vehicles. And this is really what first sparked my interest in autonomous technology. I really hadn't known much about it before this, so I was eager to take in as much information as I could. Why would I not want to learn about something basically taken right out of a science fiction movie? The difference is this is actually happening, and we're getting closer and closer to it becoming a reality in our lives. So with myself being an electrical engineering major, I was highly interested in the technological aspect of autonomous vehicles. So what makes these cars drive themselves? It basically just boils down to an extensive series of sensors placed in various regions of the vehicle. So the specific technology discussed relates to the Mercedes-Benz autonomous technology. However, any generic autonomous vehicle will be very similar in function. The vehicle utilizes what is called a stereo camera placed near the rear view mirror. And this camera is actually comprised of two cameras, which can simultaneously monitor the environment up to 500 meters away, as well as register the spatial region about 50 meters in front of the vehicle. And this camera is oriented at a 45-degree aperture angle, so it allows it to detect the position and movements of objects, so like pedestrians, other vehicles, and it can do this in 3 dimensions. Along with the stereo camera, the vehicle comes equipped with a series of radar sensors that can detect distance. So 2 short-range sensors go on either end of the front bumper, and an additional short-range sensor goes on either side of the rear bumper. And each of these have an approximate range of 30 meters. So additionally, a medium-range radar sensor is placed in the middle of the front bumper, and a multi-distance sensor is placed in the middle of the rear bumper. So all of the camera and radar data is collected, consolidated into a single control unit, so the vehicle can control system-specific data, and it can be used for a wide range of functions, such as adjusting to an appropriate speed or maneuvering the vehicle itself into a new lane. The cameras and radar system supply data that can be processed by other systems within the vehicle. So pre-programmed algorithms evaluate this data, and it allows the system to automatically adjust the vehicle based on its surroundings. This includes properly spacing the vehicle in accordance with other vehicles driving in front of and behind the vehicle, braking for pedestrians, even maneuvering roundabouts or other tricky traffic patterns. And all of this sounds incredible, but fully autonomous transportation is still a pretty long ways off. With where we are in society, the technology is capable. However, people themselves are pretty uneasy about making the transition. So expert Ralf Herrtwich, which is a head driver assistant in chassis systems at Daimler, says that once this transition happens, there's going to be a long period of time where both manually operated vehicles and autonomously operated vehicles are on the road at the same time. Because of this and some limitations in the autonomous technology, it's also necessary for autonomous vehicles to have a manual driving mode. In regards to sustainability, the timeline is as follows. Currently, vehicles are already capable of driving on their own at low speeds or in traffic jams. So this means already vehicles equipped with this technology are decreasing the potential accidents due to errors in human judgment, as well as increasing fuel economy. From tests conducted by Mercedes-Benz, it's estimated that an autonomous driving can reduce fuel consumption by up to 5%, while heavy-duty trucks can reduce fuel consumption by approximately 7% on long-distance trips. So the expert Herrtwich predicts that it'll be another 10 years or so before vehicles can fully drive themselves like a human could. So once that point is reached, autonomous vehicles will greatly benefit society. With fully autonomous roadways, vehicles can operate at their maximum efficiencies, all while significantly reducing accidents. The cameras and sensors in the vehicle will allow the system to adjust to any conditions, such as a new vehicle entering the roadway or a pedestrian crossing the street. For this reason, intersections will be able to be continuous, as there's no reason to stop the vehicle completely. By reducing the number of stops, vehicles will receive less wear and tear damage, especially to braking mechanisms, and will also produce less emissions as a whole. So in order to make this a reality, society needs to set the legal framework, as well as become more accepting of the technology available altogether. The technology will only become better and more advanced from here. So to quote the Daimler strategy model, let autonomous driving shape the future of mobility in a safe and sustainable manner.